I'd like to make a video today um, talking about oval shapes, concave, convex, eclipses. Since I didn't get any requests, I figure I'd see a lot of people are reading this, so I just thought I'd cover something else. And I am definitely no mathematician, so I want to show you um, how I came up with a system of actually drawing a correct oval. And take, for instance, like a speaker enclosure, and you had 6 by 9 speakers, and you need to make a plate or something. So I want to draw a 6 by 9 oval, and to start with, we know it's 9 inches tall. So I'll draw a 9 inch line, and then we know it's 6 inches across. So I'll just draw a 6 inch line, and I'll intersect them in the center. My screen seems to be acting funny here. Hopefully it doesn't mess up. Now, to do this, I use the spline tool. Okay, but with the spline tool, you you pull these two ends around, and that determines the shape of the concave or the convex that you're making. Now, I had to come up with a system of figuring out where to put these to actually get what I wanted. And obviously, you could spend all day trying to do it like this and never end up with anything correct. So, what I figured out was one, I had to put the lines, I had to put a line evenly spaced on the top and the bottom so that when I'm pulling the end of the spline tool, I'm pulling them evenly into the same locations on the top and the bottom. I didn't draw that line straight. Let me make it 0. And the first way I tried to do this was I took the difference between um, the length of the 6 inch line and the length of the 9 inch line, because I looked all over trying to find the mathematical equation for this, and I'm no math wizard, but through trial and error, I figured out that this is 6, this is 9, the difference is 3 inches. So I multiplied that times 2 and used that for my initial setting. And what I found was um, if I put a 6 inch line on the top and duplicate that and put one on the bottom, that I could get pretty close. And I'll show you what I mean. Like I say, hopefully some of the math wizards pop in here and help me out with what the actual equation is, but I'll show you the one I found. And it seems to be working right. Now, if you notice, 6 inches is not long enough. It has not brought this point out far enough. And I'll show you what I mean by grabbing the end of this one again. I have to pull it out further this way to reach my destination. Okay, so 6 wasn't long enough. Well, by taking the length of the leftover line here, multiplying that by 2 and adding it to the top line, um, each time I did that, I'd step out further, but I still left a piece, and I kept leaving a piece and leaving a piece. Well, each time I kept adding that to, doubling it and adding it to the length of this line, and finally I came up with the length of the top line that actually would bring the center of this out to match exactly. Well, once I found that, then to come up with the correct formula for determining the length of this line, um, I divided the center line into the top line, and it ended up being a ratio of 1.3333 on into infinity. Well, I found that is the formula that actually works no matter what size oval you're wanting to make. So I'll go ahead and show you what I mean. If I take, let's go ahead and delete everything off of here. Delete the top and bottom lines. We have 6 inches, and I'm not going to show the calculator, but I have 6 times 1.3333 1.3333 equals, I'll go 4 spaces, and that comes up with 7.9999. So it's 8 inches. So I'll draw a line 8 inches, 2 of them. And of course I went back to my old habit of not holding the control key. I'll hit Control D. Now if I take my spline tool and put it in here and draw the points around to the ends of the lines, I'll draw a perfect ellipse, or half a perfect ellipse. And you can see that they made up exactly now. Now to get the other side, obviously I would just draw it. Like I said, I'm no math wizard. I'm just trying to show you how I've figured out ways of doing things, and I'm sure a lot of the people that are playing with this stuff kind of steer away from it because of the math. But once you determine, what the correct length of the top line needed to be, then you can just, like I said, you divide this into the top, divide it into it, and see what the actual formula is. Now that actually works. That is the correct oval shape for a 6x9 speaker. And but there's different size ovals, and a good example would be, let's say we needed an oval shape. I'm going to start with a new drawing here, and we needed an oval shape to fit, let's say 7x2. So I will draw a 7-inch line. And a 2-inch line. Now for this, we would multiply 2 times 1.333. And that comes up with 2.6666 on into infinity. So we'll put 2.7 as our top line. Or we can put the 2.66, carry it out a few. Of course, I didn't hold the control key again. 2 point. Alright, we'll carry it out 4 digits and rounded it off anyway, and duplicate it. And I'll show you the formula does actually work. We grab our points now. And now we have a 7x2 eclipse. Okay, well, so much for eclipses and ovals. Let's say that I'm going to go ahead and delete a few lines off of here. Once we have that top number, let's say we don't want quite as deep. We need a concave to fit into the side of a shape. We need it to be a certain depth, and we need it to fit in within a certain height. But we want more of a gradual slope here, instead of having a sudden drop off in this section and then flattening out in the bottom. And the way I've found to do that is by using the same length line on the top and the bottom. And I'll just draw a 1-inch line here. This time I'll hold the control key so it snaps to position. We'll make that a 1-inch line. By pulling the intersect point, those whatever they call them, the little handles that you pull to move the spline tool around. By pulling them to a lower location, I'm going to move this down 1 inch, and I'm just using this as a measuring tool, and move this one up an even 1 inch. We can make a more gradual convex, and I'll delete this off. It's easier to just redraw it than it is to try to pick up the lines and move them for some reason. Now if I pull these in, you'll see that I've got a much more, it's still going to intersect right here where I need it to, and at the top and bottom where I need it to. But now I have a much more gradual shape to this. And if you actually need just a round shape, then obviously you would just drop a radius in way out here and do it. But this is not a radius. This is an actual ellipse. So one of the things to remember, if you draw something like this in your CAD drawing, these are splines and not arcs. So in a DXF format going into a CAM program, it won't recognize this line. So in order to use a line that you've drawn like this, what you would need to do is, I'll show you in just a second. Let me go ahead and delete some of this other stuff off of here, get it out of the way. And if I select this line now, we know that you couldn't draw that line by putting a radius out here and pulling that arc because of the difference in the shape here. And a CAD program won't recognize this. It has to be converted to arcs. So if I select this line, it'll show it as a spline. And it has to be converted to a series of arcs for it to be recognized. And the way to do that is you go to line, go to transform, and then just say simply convert, and I put 1,000th tolerance. Now if I click on my line, you'll see that it's a series of, let me select it all so they all highlight. Now you can see that it's a series of arcs that are all coming from different center points. Each one of these has its own center point, and the CAD software will recognize this as arcs instead of splines. If you forget to do that and all of a sudden it doesn't show up in your CAM software, it's not in the picture, or it's in the picture but you select it and try to use it and it won't work, that's why you forgot to actually convert it to arcs. So this is just a short video on playing with, convex, concave shapes, ovals. You can make any size oval that you want, and how I've learned to work with it. I'm sure some of the mathematicians would have come up with the way of that 1.3333 a lot easier than I did, but I got it to work. So thanks for viewing, and I'll try to think of something else to put up here for those that are still watching the videos. If you have any comments or you'd like to see something else, even if it's something I don't know, I'll at least look it up and try to figure out how to do it. So until the next video, thank you.